everyone. Welcome to this next session of our ESCFI Partner Spotlight. We're very excited to have Vic Stampson with us today from Argument-Driven Inquiry. As a former STEM educator, I am very excited about the solution that you created, and the great things I think will come out as you're sharing your program with everyone is that you are a former educator, and this grew out of what you did as an educator and found worked well with students. And again, we are doing this live stream in support of schools who want to apply for that new round of digital learning grant funds. And so we're excited to connect you with partners. And ADI has made an official partnership with the Educational Service Centers of Indiana. So if your school district is a member of one of the service centers in Indiana, and most are, you have special member pricing because of this partnership. And with that, I'm going to turn it over to you, Vic.
Awesome. Thank you so much. I'm really excited to be here. So we'll dive in here real quick to talk a little bit about argument-driven inquiry and the things that we do and how we can help you out. Before we start, a little bit about me. I'm a former high school biology and chemistry teacher. I taught in Washington State and Arizona for about 8 years. Got my PhD in science education from ASU, and I was a former associate professor of STEM education at Texas, where I researched how to help people learn and how we can design new instructional models that promote and support learning. And that is really where ADI came out of. I retired from Texas just this year to take over as the Chief Innovation Officer at ADI. So that's my Twitter handle if anyone wants to get a hold of me that way. But we'll go ahead and get started here. So big thing is to think about how you can use argument-driven inquiry products and services to meet kind of three of the major priorities of the digital learning grad, right? So I think what we do is really well aligned with building teacher capacity and learning for high quality blended online learning. And I'm going to really focus on how you can do that with argument-driven inquiry instructional tools. Implementing strategies to address academic impact. We're really focused on making learning experiences that are rigorous, equitable, and meaningful for kids, and really helping them grow over time. And then you can use absolutely the purchasing and implementing technology tools. We have a tool that you can use to make all of this stuff happen, which I'll tell you all about. So let's go ahead and get started. What we try to do is create learning experiences for kids. And what we do is we build this around an instructional model. We do this in engineering, science, and mathematics. I'm going to focus on science today just because of the short time we have together, but we also have resources for math and engineering. And if you're interested in learning more about that, I'll let you know how you can get in touch with me after this. But we have this instructional model that we've developed through research, and it was tested over 8-9 years in actual classrooms through classroom-based research in collaboration with teachers. So everything we built was not from kind of a theoretical lens. It was this idea that we're going to take these ideas about how people learn, we're going to build them all around that, and then we're going to test and refine it in classrooms based on the needs of teachers and students. So this instructional model has 7 stages of activity. I'm going to kind of go over this with you, how this looks like. But it provides a nice framework for promoting and supporting learning in a way that makes it helpful for teachers who are learning to teach in a new way. And it's helpful for kids because it enables them to really engage and use the ideas and practices of science, math, or engineering to figure out something about the world around them. What else is really we're proud of is that often people will say this is a research-based approach. That usually means that they've taken some principles and findings from research and try to incorporate that into instructional materials. Ours is built through research. So if you do a Google Scholar search of argument-driven inquiry, you can find over 40 different peer-reviewed articles conducted by lots of different researchers, including myself, that looks at studies that have studied what people learn from this in grades 3 through college and a wide range of contexts. So this is a very research-based kind of thing. Now, over the years, we've really been thinking about what makes ADI special and what it does to promote and support learning. And it's really built around 5 key pedagogical features, right? So you'll really see this in what we do and what we build. The first one's that students are given an opportunity to make sense of a phenomenon. And that's just some observable event in the world. So students figure out why or how things are happening in the world around them instead of just learning about concepts and terms. And so here's a couple pictures of examples of that, of how you might be able to make a acrobat on a teeter board fly higher. Or if you attach two batteries to two magnets to a battery and put that aluminum foil, it'll start rolling. Why is that? Or here in Texas, we have these huge hailstorms that happen during different parts of the year. Why does that happen, and why does it only happen in certain locations? So these are all things that we observe in the world around us, and the idea is to encourage kids to have a chance to figure out why those happen. The other big key features is we encourage students to use their own ideas. Kids are brilliant. They have amazing ideas and experiences, and we want to leverage those. But we also want to help them use disciplinary core ideas, cross-cutting concepts, and science and engineering practices to make sense of these phenomena, right? And there would also be mathematical practices as well. So this idea that we're focusing on kind of three things: the theories and laws of the discipline or the concepts, the practices, what people in this field do, and then the cross-cutting concepts are kind of the frameworks or lens of thinking about things. So we think of this from a perspective of energy or cause and effect or structure and function, those kind of things. This graph this table here kind of shows you a quick overview of what this might look like and how often kids are able to use these ideas and practices. So on the left column is the different stages of ADI, which I'll go into more detail here in a minute. But the next column is the ideas that are introduced or kids are encouraged to use. So DCI stands for disciplinary core idea. CC stands for cross-cutting concept. So in multiple stages, they're encouraged to reflect on, think about, use these ideas. And then the last column is the practices that go on that kids use to figure things out during each stage of this instructional approach. Third big feature is that students are encouraged to read, write, and talk as they obtain, evaluate, and communicate information in the service of sense making. And this is important, right? So instead of asking kids to develop reading skills or writing skills or speaking and listening skills kind of devoid of content, we frame those as using those skills as a way to make sense of something happening and to do the practice of obtaining information that I need to figure something out, evaluating the quality of that information, and communicating that information to others in a very clear way. It's a central part of what we do, and gives kids a chance to see why and speak and listen and the disciplines. To kind of illustrate where that happens during this approach, here's another table for you. So here on the left is the stages of ADI, and then the next three columns are reading, writing, and speaking and listening standards that you tend to see. On reading, there you can see during 2 stages, you're really focusing on reading. Writing happens during 3, and speaking and listening happens during 4 of those stages. So what's nice about this is anytime you do one of these in investigations, kids are automatically focusing on all of these literacy skills at the same time as a bonus as they're exploring and learning about key content in the subject areas. Fourth key feature is the model gives students more voice and choice in deciding what counts as high quality. Instead of everybody just saying, hey, here's your rubric, exactly what you're supposed to do, is this right or wrong, we encourage kids to talk over what counts. It encourages them to value different people's ideas and participation as helpful for sense making. So we want kids to adopt these criteria of what counts as high quality by discussing them and seeing why they're important. So we make that a central feature of what's going on. And then finally, what I think is probably most important, it creates learning experiences that have a low floor and high ceiling, which means anyone can get into start doing these investigations, and you can take them as far as you want to. There's plenty of room for differentiation in terms of, hey, I'm interested in this, I want to go this way. It includes these learning experiences provide multiple types of interactions with ideas and materials and people, incorporates support for those who need them, and pushes all students to think in new ways and learn from their mistakes, right? So that's really how these things are framed, whether you're doing this in a 3rd grade classroom or a high school chemistry classroom. So that's kind of the big overview. So what we did is we created what we call the ADI Learning Hub to make it easier for teachers to access and use these investigations. Let me show you a little bit about what this looks like here for you. So at the heart of the Learning Hub are investigations, and we've created a library of these. We have a library for math, we have a library for engineering, and we have a library for science, right? So this is a picture of that part of the library, and these cards make it easy to figure out what's the topic of the investigation and what standards, practices, cross-cutting concepts, and ideas that you're looking at. So for example, if I'm a biology teacher and I want to help my students understand population dynamics in an ecosystem, right? So what I can do then is I can look through this library and I can find there. So in this case, I've got 2 possible investigations that I can look at. I can view the investigation and then assign it to my class. Then what that ends up looking like is we run them through the stages of ADI. Now, this is not a scientific method, or it's not a thing that kids need to know they're on stage 1. It's just an organizational tool for you as an educator to kind of think through this. So in stage 1, what we do is we introduce that phenomenon we talked about, and we elicit students' ideas about that. That's almost always done with some kind of video. In this case, it's a news article about a group of people reintroducing bighorn sheep to a lake in Nevada. And what we can do this is we can do this both in person or virtual using the Learning Hub. So if you want to do this in person, you can use the Learning Hub as a teacher to shine that video up on the screen, and then you can download handouts out of Learning Hub and give those to kids, and then they can talk about write down things they notice and wonder about when they're watching the video, and then write down some of their ideas that they have about what could be going on and some things they need to learn about, right? You can also switch that over and do it hybrid or online or remote or paperless for that matter. In that case, then each kid could go on to the Learning Hub, they log in on their own, they can see the same video, and then this time instead of a handout, they access what we call a collaboration board, which gives kids an opportunity to share their ideas and comment on each other's ideas and things like that. So you can have the same kinds of learning experience, whether you're in person or online. The second stage of the approach, we call this ideas. And what we do is we highlight some core ideas and cross-cutting concepts that students can use during the investigation. Now, the idea here is not to teach them everything they need to know, or actually what the answer is to understanding that phenomenon, but it's to put some ideas on the table, pieces of the puzzle, so to speak, that they can use as they're making sense of what's happening, right? Before they really have to start thinking about planning and carrying out the task. So we can do that 2 ways, online or virtual. In person or virtual online. So if you're in person, we have these handout once again. We can have, you can print these out, give these to kids. You can read these aloud to kids and then have them group up and talk about some things they know, or they can read them by their own and then talk in their small groups. The idea is to get them just kind of encouraged and looking for things that they find important or useful. If you're online version of this, don't need the handouts. You can just have kids log in. They'll see the same text and the same pictures there, and then they'll have a collaboration board once again that allowed them to interact with their peers to talk about what they thought was important from the readings or what would be useful, because these ideas are just tools that they can use to try to make sense of the phenomena they're exploring. In the next stage, we call that plan. We ask students to create, share, and revise a plan for collecting or analyzing data. So we've listed their own ideas, we've introduced some ideas, now they're going to figure out an investigation that they can use to answer the guiding question. And in this case, for this example of this bighorn sheep, they'll actually use an online simulation where they can test factors. This is really helpful for biology because in biology, we tend to study things that happen over long periods of time or over large areas or over generations, right? So we can use simulations to give kids a chance to still design and carry out their investigations. So if we're doing that in face-to-face, what we can do is we have these supports for kids planning out their investigations. We call them just proposals, and they're just kind of a graphic organizer where kids can fill these out together and then share them with the teacher. You can see me working in the classroom here, and then we give them feedback. If you're doing that online, kids can download a Google Doc or Microsoft Word, fill out that proposal, and then they can upload it into Learning Hub, and then that'll be assigned to other students to give feedback on that. And we have a tool built in that allows them to drop pins on their work and give each other feedback that they can see on how to improve their investigations. From there, kids have this plan, so we have them go ahead and do it. They collect the data they need and they make sense of it on that, and they should really have an answer to the guiding question. If you're doing that in person, we can have them access the simulation through the Learning Hub and they can collect information on handouts. If you're doing that virtually, all that information is right there in Learning Hub and they can collect their data on the computer as they're using the simulation. What we try to do here is, because we really are focused on blended learning or in-person and remote all in one same tool. We try to build different versions of the investigation data collection, so it's both hands-on and person. So for example, if you're doing chemistry and looking at gas laws, the in-person version, we can set that up as a physical lab where they're doing hands-on data collection. The remote version would be using a simulation. Now you can blend those and you can still use the simulation in class, but we're trying to give as many options with allowing kids still have the voice and choice about how to figure things out through this. So it's a nice tool for that. Next stage, we call it share. And what we have students do is create, share, critique, and revise an evidence-based argument about what they figured out. So if you're doing that in person, we recommend kids do that on these large whiteboards. They do a modified gallery walk where they can share out and give each other feedback. And there's a handout that allows them to write down some ideas for improvement because they need to go back at the end of the stage and revise their argument. If you're doing that remote, we have that all built in so they can still have those kinds of interactions. In this case, they would make their argument on a PowerPoint or a Google slide. They upload that, then they can screen capture, kind of like what I'm doing right now, and then that can be uploaded, and then they can peer review each other's reports using that same pin drop tool by watching a video and dropping at the minute 30 mark or whatever a comment. So it's a really cool way to get kids interacting and working on that speaking and listening at the same time. Here's an example of what an argument might look like for this investigation part. So a lot of big thinking goes on when they're putting these together, and it's definitely not a worksheet or a multiple choice kind of test. We're really getting kids to kind of think through what's happening, what's going on. The next stage, we call this reflect, and we ask kids to kind of discuss the ideas and practices they were using. If we're doing that face-to-face, we usually have the teacher can project a question on the board and lead a whole class discussion. If you're doing that remote, same picture, but we have that collaboration tool that allows kids to talk over stuff once again. And then finally, we go to a report stage where students write, share, critique, and revise a report about what they figured out. If you're doing that face-to-face, we have handouts that have sentence starters, peer review guides to review, and then they can finalize their report. If they do that online, they can download a template, submit that, and then they are sent through a formal peer review that has a rubric that allows kids to kind of give each other feedback and improve that before doing their final draft. Once the final draft's there, they can submit it, and then you as a teacher can use the same criteria to score it. So what's also cool about that is that if that's what the investigations look like, we also have a ton of extra tools to make it easier for teachers to use these investigations, right? So we have, the teachers can create up to 8 classes in these and assign as many investigations they want to each class. Once you assign an investigation, you can set prerequisites, due dates. You can set the stage for being remote or in person, however you want to do it. And you can switch it out after you've already started it. There's dashboards that allow you to see kids' progress on each stage, where they're at, what they have to get done, when it's due. And then you can also click the button that says view submissions. And then you can see exactly what they've put in there, and you can delete things and see all of their work in there. So it's a really nice little tool to be able to monitor kids' progress. Once you've graded, you have a tool that allows you to see reviewer ratings, the student report grades that you've given for that, see what it is on a class average. But most important, we've added in tools that allow you to track growth over time. So you can go to this feature we call Insights. And for any investigation you've looked at a class, you can see how everybody in the class overall has done over time and how that progress has changed. Or you can look at individual students. You can compare your first investigation to your fifth to your 8th, however you want to do that. So it's a really nice way to track growth and really focus on learning rather than just completing activities. So as I wrap up here, I've only got a minute. Some things to keep in mind as you think about your proposal for the digital learning grant or partnering with us. Is always think about the nature of the learning experience that you want to help people learn, right? So ask yourself, are we giving students an opportunity to figure things out by interacting with others, or are we just delivering information to us? Because when we change it to figuring things out, it's amazing how much kids learn and how much they love school. The second thing to do is always think about how important it is to get access to teachers to high quality instructional materials that were designed to create learning experiences like this. Not everything is done that way. A lot of things focus on memorization, vocabulary, memorize the basics. But you can do your really amazing things if you get these high quality materials to kids. It can really transform what happens in the classroom. I always love to see tweets from teachers using this to see what they're able to do on that. And then finally, the use of high quality instructional materials can act as a catalyst for professional learning, not just being an objective. So how can we use these materials to support ongoing changes in teaching? So one of the things that we always do is we provide tons of professional learning. So we have all of these different kinds of workshops, facilitator institutes. Sky's the limit of how we can support teachers learning to use these materials as catalysts for change, not just as you must use them kind of thing. So I'm going to wrap it up there because we're at the 20-minute mark. If you want to learn more about Argument-Driven Inquiry, that's our website. If you want to get a hold of me, there's my email and my Twitter handle. I would love to talk to any of you about any possibilities.
Vic, thank you so much for being here with us today and sharing the solutions that you have to offer. They align absolutely perfectly with this grant and with the state's actually updated STEM plan and the STEM school certification process as well. So very happy to be partnered with you.
Thank you so much. I really appreciate it. And once again, please let me know